must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will face my fear. I will permit it to pass over me and through me. And when it has gone past, I will turn the inner eye to see its path.
Where the fear has gone, there will be nothing. Only I will remain.
I'm afraid I can't explain myself, sir, because I'm not myself, no.
On this episode of the Hacker Homestead, we're going to get the uCamera application to my desktop so I look at it with binwalk and a hex editor, SDK, Chinese documentation, see what kind of clues we can find. I'm going to write some C.
C. Explain yourself.
Grab a cup of coffee, some tea perhaps if that's your persuasion. For those of you who are joining us for the first time, welcome. You can stick around, but you would get a lot more context for this if you watch the previous parts. Part 4, the software episode. I've got my screen command up here that I use to connect, and it's going to be critical for this next phase because what we're going to be doing is logging in and transferring the application. There were several suggestions for how to do this directly using LRZ or DD or even the terminal. And I definitely want to explore those. This is the method that I used. I'd like to test out the other methods. They make a lot of sense. I'm trying to go for one that is straightforward for everyone. We're going to be using the application screen and giving it a log file. Our log file is part 4. We're connecting to our USB device, and the last argument is our speed. We're going to go ahead and connect. So, blank screen, hit enter, get my prompt, root. I'm on the root console. Now, if you recall from last time, in the system bin folder, there's uCamera. And I want to go ahead and get that binary to my desktop so that I can binwalk it and get a little bit of an idea of what kind of binary it is, because we're going to be writing an application, seeing if we can actually run something new on here. So I don't have binwalk. It's not on here. And you just never know whether you're going to be able to get a binary over and execute it. So we're going to start out with being able to extract uCamera. How am I going to get that across, especially if I didn't have anything else but the serial connection, in this case screen. So that may mean that I don't have a great facility for transferring a binary file. So blah, 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 blah. I'm going to take a very simple approach to getting this uCamera binary down to the desktop so that we can do some analysis on it. And the way I'm going to do that is leverage the fact that I'm already logging to a file on my desktop. So we're going to do that by just saying base 64, which when given no parameters, here we'll see if help works. So when given no parameters, base 64 will simply just encode the file and put it to standard out. So we're going to do that now. Base 64 and then the name of that file, uCamera. And I'm going to hit enter, and it's just going to scroll through on the screen. There's a last one that was particularly exciting that was suggesting using the ADB-D daemon to fire up USB. We're going to get back to that. Unfortunately, we're just going to get back to that. All right, so I've spit out my file, and what I'm going to do is go ahead and disconnect. Now, if you're in screen, you can either do a Control-D. That was not the right answer. In screen, you can either Control-A, then you enter in a command disconnect, which just disconnects me, right? in which case then if I look at part4.log, yeah, sure, I'll look at it anyway. It's a binary file. You can see that there's text within my binary file. It's just that you need to be careful with these files because technically they do have these control sequences embedded within them. This is a nice way to use screen because screen is actually still working in the background, and you can do screen-R and reconnect and you're back there. If you actually want to quit your session, which effectively disconnects you, right? You can, and it'll stop the log file. You can do Control, I did it again. Control A, and you can type in quit. I think there's another combination for that, but I've forgotten it. Okay, so now we've terminated the screen, and I'm going to copy this part4 log that contains the session information we want, and call it ucamera.base64. Whoa, my hands are still warming up today. And then I'm just going to go in here with VI, or maybe with Vim or NeoVim. So I have a few more features, and you can see we've got this output. Now I remember, last time I did this, it was a much bigger file. So you can see where we issued this command, base64 ucamera. What we're going to want, see how these are different lines. What we're going to want is just like a statue. We're going to carve this out. So I'm going to go back up to the top of the file, and there's not many lines, so I'm just going to do it manually. And I'm hitting DD. Okay, we're on that actual file. I don't think I need that last J. I think it's part of one of the control sequences. So we're going to delete that. Then doing a Shift G. And we're going to go to the bottom of the file. Yep, that's right. I'm using visual mode and hit delete. And then lastly, I'm just going to clean up that last character. We're going to write and quit. Now we have our ucamera.base64. I'm not going to dive into base64 right now, but there is definitely redundancy built into base64 because you're taking this binary and you're expanding it. So if I was to go back into all right, so ucamera is 685 kilobytes. So I Control A and disconnect. You can see that it's 938K for the ucamera base64. That's more. It's not double, but it's more. Enough of that. Now if I look at base64 here on my default Ubuntu installation, it's saying invalid input. Let's go ahead and ignore garbage. It went ahead and took it. Now we have the ucamera. Now what we're looking at is a ucamera.bin. You'll notice it's 686 kilobytes. If I bin walk that, we now have, yummy, an ELF 32-bit LSB MIP64 executable. And that gives us some information we need to know about what kind of programs are on the device, more, the architecture, for example, whether it's 64 or 32-bit. Now we know that ucamera is a MIP64 executable. Okay, that's great. It's not like we can run it here. unless we had like an emulator. But what we can do is use a hex editor to open it up and look at the strings. This is not the one that I used. What did I use? Hex curse is the one that I used. Yeah, this is really nice. We have the memory address on the far left, the actual hexadecimal values in the middle, and then off to the side we have the text representation of those hex values. So for example, you can see that this was leveraging lib-ld ulibc, right? So you start to get clues on what is in the binary, how it was compiled, assuming it wasn't obfuscated. Now, as much as I would love to do this, in fact, like just scroll. My bad. Before we jump into the hex notes, we should run an MD5 sum. MD5 sum ucamera.bin. So this should give us a really good idea as to whether the files are exactly the same on the source and the desktop. Here's our MD5 string that we get that should be mostly unique to this binary. And then I'm gonna, do I still have it running? Yes. ucamera. Okay. D9C0, D9C0. All right, fantastic. Those are the same. We know ucamera is the same. We didn't lose anything, didn't lose any bits along the way. Jumping into text editor. This is a great way to take notes on the strings that are included. The strings that are included are not always super helpful, but if they leave error messages, right? So anything that they print, in general, anything that they print is going to come out in here, and then you can track it down. Basically, you can track down the string to the function, and then the call, and particularly if you're starting to thinking you might have to disassemble to really reverse engineer the binary. This is always a nice smooth start, is to go through the hex and pluck out all of the error messages that are particularly interesting. I'm just going to kind of go with it. These are maybe supported processors for this application. See if there's anything else interesting in here. Found some interesting things in there that we'll get back to. For our next step, we're going to write a program and try and get it to execute on the device. This is our clue. We want the binary to match this kind of execution, or at least be close enough for a MIPS executable. To give you, to start into this process, to try and slide into writing an application for this, I did prepare just a hello world in C. At this point, it doesn't really matter whether it's C or C++. I know that may incite quite a few comments, but all we're doing is printing hello world and returning. I don't know. Oh, this is so simple that I'm having a hard time explaining it. Quit. And then what I can do is just make that. So I'm gonna use GCC, and we're gonna give it a source file, hello.c, and our out file is hello world. Okay, no news is good news. Hello world. All right, cool. More importantly, let's do a bin walk on this hello world, and we can see that it's a 64-bit AMD x86 64. Bin walk. Our ucamera.bin. You can see that One of them is for the chip architecture x86, which is normally what's on your desktop, unless you have a Mac, in which case it might be an M1, yada yada. But the two architectures we're working with here is an Intel AMD x86 platform or a MIPS platform. The MIPS platform is our target platform. So how can I do this so that I can compile that C application for MIPS? There's several different ways to do this, and this is where you can get into a whole rabbit hole of its own. Cross-compiling. We're going to try and take the easy way, which, rolling back to down the rabbit hole, we found a software development kit on GitHub. I don't think that it was official, but let's use it anyway. Well, there's some good things here. Like, look, we have a samples directory. Oh, we have some documents. It seems definitely like something that I want obtain. In fact, oh, snap, right? It's got a tool chain. My fans are kicking in again. I hope it's not affecting my audio. I used Git on the command line to bring this down, but it doesn't really matter for what we're doing. If we go into the directory, there is a doc directory in here. Okay. This doc directory has a couple PDFs, and then, oh, hey, look, html.en. It's got an index.html. Fantastic. Let's bring that up. This is the HTML documentation that they rendered out, and you recognize we get a nice little outline of this. We saw a reference to some of these already in the hex, but this starts to give us even more clues into the capabilities of the chipset. We've got things like move detection, we've got encoders and decoders, we've got the intelligent analysis common API. It's not necessarily always going to be a getting started guide, but look at this. We even have things like samples and explanations of those samples. And so this is fantastic, right? This is a treasure trove. This is a treasure trove of information, but it's just not really quite telling me what I need at the moment. So we're going to open up the PDF. This is crude, but effective. By the way, I don't read simplified Chinese, but Google Translate is fantastic. Here's our manual. If I just kind of look down here, oh, we've got information on U-boot, but oh, here we go. Toolchain. If you really want to know what the simplified Chinese is, Google Translate, and boom. We're installing 7-zip. We're decompressing. Looks like we're editing our bash RC, export this path to MIPS. Okay, so, all right, so you kind of get this idea, and then they have a confirmation. Let's go ahead and do that, but I need to set the path. So if I go back up to Toolchain.
Now we'll export the path. Export, and you can do this a couple different ways, but I'm just not going to edit my bash RC at the moment. So this is in Home, Handy, Projects, this dude, Toolchain, some tab to help me, GCC 472, remember that's 32-bit, MIPS, bin, okay.
And then we'll tack on our existing path. Let's go in the samples. All right, I'm going to fast forward here a little bit. In this sample directory, we have a Makefile, which means they intend for us to batch make these. And if I just look into it really quick, I'm going to clear this out, and then I'm just going to type make. Hey, there are some warnings, but look at that. We have executables. I'm going to do a bin walk. How about we just copy our Hello World application into here and then compile it. So Home, Handy, Projects, MIPS, Hello World, hello.c. Just copy it in here. All right, hello.c. And then we'll go into our Makefile. If we go down, that's our list of samples. So let's just follow along with, it's not really what I wanted to see. I must have done this in an odd way. Let's go to libimp. This is where I made it before. VI, Makefile. I have hello in there. And if we go down to the end, we also have hello. I'm going to quit. I'm going to type make. I'm going to do bin walk hello. That's what I want to see. All right. Well, whatever. We'll go with this version. We're hacking. We're not being pros today. Now that I've bin walked this, we have a 32-bit MIPS executable. If I was to bin walk home handy ucamera.bin, you'll see that it also has the same thing, right? So it also is the same. 32-bit LSB MIPS 64 executable MIPS version 1. Okay, great. Don't pay attention to the Unix path at the moment. Let's look at this. Let's look at how large it is. It's super kind of messy to do it in here. So what I'm going to do is I'm going to copy that hello out to home handy. It's just kind of messy to create files that don't have to do with the actual compilation in that make directory, because then when you do like a make clean, it's not going to clean up those files unless you tell it to in the make file. Oh, make files. We have a binary. We need to get it onto the box. Again, I'm going to cheat or take the easy way. I'm going to convert this using base 64. Base 64 hello to hello dot base 64. Let's just look at it. Sure. MD5 sum it. MD5 sum hello base 64. Here's the part where I cheat. I'm going to open up in Pluma. So Pluma. Yep, this is the file. So all we're going to do here is reconnect the screen. Use temp. Okay, so let's take this out. So I'm going to use temp because there's plenty of space and I won't be using the flash memory's write cycles up. All we're going to do, go into temp, vi hello dot base 64, a brand new file. I'm going to hit insert, then I'm going to Control A, copy, and paste. Now, I have 71 lines. I have 71 lines. Looking good. All right, quit. MD5 sum hello base 64. 4B83. Control A. Disconnect. MD5 sum temp hello base 64. 4B83. In case I took it out in editing, I had to copy it to a temp file, or I had to copy it out of this directory because handy is not what I'm running the X session on. Anyway, doesn't matter. Okay, so the MD5 sums are the same. We're going to reconnect. R. Here we go. We're going to, so base 64-D, give it the file, output to hello.bin. Fantastic. chmod +X so that it's executable. Hello.bin. Fantastic. See now the execution bit set, and we're going to MD5 sum hello.bin. Control A, D, MD5 sum hello. That's 6707. 6707. I think they're the same. Let's run it. Drum roll, please. Hello.bin. Boom. We ran an application on our web camera. now that we can write an application, we know that we can write an application, we have a tool chain, we have access to some documentation, we can really start getting into not just this camera, but this chipset, right? Now that we have access to the data sheet, the documentation, the tool chain, we've confirmed our assumptions along the way of being able to connect to it, being able to write an application, being able to execute it. Now we can both expand our approach. So for example, going after that FPGA, trying to write our own camera application, maybe even flashing the whole system. So we have this baseline of expectations of what we, of operation. Also, we can optimize. So we can optimize how we're connecting, how we are transferring, the whole workflow. There are times to rush, and then there are times where you need to take one step at a time. Thank you for joining. Thank you for going through this. There'll be more. My special announcement, if I didn't already mention it, was I'm going to make this into a Tinker board. We're going to take this T31 chip, make it into a Tinker board. Using PCB ways, turnkey service, we're going to design, implement a Tinker board similar to an Arduino or a Raspberry Pi. I hope the cost is actually lower and the availability is better. But I like the idea because it's actually less curated, and there are some specialized uses for this chip that ESP32, Raspberry Pi, Arduino just aren't as suited for so much. Like particularly along the voice and video. I'm Handy. Happy hacking.